Hey guys, welcome back to the channel. I have another Marine ECM, this time working on a 5.0 Volvo Penta. This was sent to me by Paul Mohan, or Mohan, sorry. Sometimes a little hard for me to know exactly how to pronounce your names or last name. All right, so this is a MEFI 4. His concern is no 5 volts. He has a technician already looking into the boat, and then, yeah, they cannot start it. They got no 5 volt reference. So I have right now the computer is actually connected and on. So let me turn this on completely. So one thing that we always look for, especially on MEFIs, is the activation of the fuel pump. That will tell me at least the microprocessor is alive. So let's power this on, and this is a very good sign. Even though we have no 5 volt reference, because I can see here we got no 5 volts. But that is a good sign that the actual logic of the microprocessor is still good, which is great news. We don't know still yet because 5 volt, 5 volt regulators circuits on these computers is a 50-50 chance until I open them to see if it's repairable or not. But this is still a good sign. All right. So we're going to connect, and this I'm using Diacom Marine software for laptops. This is the best system. It covers a lot of the Marines that I offer services for. All right. So I'm selecting MEFI 1 through 4, and then I click OK. This is also good sign as well. It was able to talk to the computer. So let's connect and see what codes we have here. All right, so we got two faults. Throttle position sensor voltage high, manifold pressure sensor voltage high. Yes, definitely that's an open circuit, no 5 volt reference. Okay, so we definitely know that that is the case of the computer. Since I'm in a control environment, I don't really need a computer 5 volt reference to produce the signals. I can from my simulator, put the TPS signal, the coolant, and all those signals out on how the computer is expecting it and then make it run. So let's make it run. And sign number 2, it is running. So this is a good sign. So the logic and everything else on the computer, including the IEC, which I have a substituted value for, is working good. So this is definitely good. Let's look at the signals. I have the oscilloscope right next to here. So we have blue channel for injector on bank 1 because this is a batch fire injector system. So we will have one in the blue and one in the red channel. So both banks are good. And we can see that here, right? So we got 2.5 and 2.5. That is a very nice and clean signal because my simulator, when it can put numbers, that means the strikes or the activations is a clean activation. So that's also a really good sign. The EST signal, this is the coil firing. It has an ignition module. And then the yellow is the tachometer signal. Again, all those are very important signals. And I can see that the computer is able to control and work. I'm going to raise the RPM because right now I wasn't like at 800. I want to go up to like almost 4,000 RPMs. And you can see the changes on the signals as I go faster. All right, we're in 4,000 and something. So I'm going to change the throttle position, which I was right now like around 40%, and I'm going to change the map value. Again, you're not going to be able to catch that right away, but I will point you right here, total position around 40%, and then the map value around 16.2. This should change the injection milliseconds, and it did. Because you see right now we got 4.2 milliseconds, and it's clean. We can see, nice and clean strikes, not like a multi-strike. When I have problems with the injector drivers, this is the way that I reproduce them immediately. I can see multi-strikes. It's not like a activation, ground, remove the activation, because remember, it's an injector, so it will be ground side activated. So all that is a good sign. So Paul, this is, yes, I can definitely reproduce your concern here. So we definitely have a problem with the 5 volt reference. So I'm going to open the computer and then see my findings and then give you recommendations and if the computer can be repaired. All right, guys, I called Paul and he approved the repairs. Computer is ready. I'm actually going to do the test now with the computer fixed. All right, so the computer is connected but no power on. So I'm going to power on. We saw the fuel pump coming on, but we're going to repeat that process and I want you to see that. Now we got the 5 volt reference fully operational. which is great. All right, so now I want to reconnect Diacom. Let me also set up the lab scope 1 second. Okay, I got everything ready to go. So let's reconnect. So I'm going to go over to the selection, select the MEFI forwards. This should establish a connection properly, and it did. Okay, now we're going to reconnect. We still got the true fault code, so I'm going to erase those. And there, if they're not coming back, that means good news again. Computer is fixed. All right, so let's run it. This will be running in idle. Let me also run the scope because this is stopped. All right, we got everything in there. As before, we saw the signals were clean and working good, so that should be no change. But now, what I want you to see is that we got 0 trouble codes. It should be the 7 line from the bottom up on the right, like on the screen. And we got RPMs, 800 RPMs. I'm going to do the same thing, raise the RPM around 4,000, and we see the changes on RPMs. And I want to stress the computer to make sure the sensor signals are staying properly. So we got around 4,000. Let me change the TPS to around 30 or 40% and change the map values to around 16, 17. And we can see the milliseconds of injection being nice and clean. And we can see that on the screen. So all this was good, no problems, but the fiber reference was never there, which is good. All right, so the computer is 100% fixed. Talking to Paul, I said, okay, this is a damage on the boat. The damage is computer, so let me get the idle values before I turn this off. So whenever I need it back, I will be around the same values that I usually use for testing, so around 12.5 or so. And we can see the difference on the RPM sorry, the injection milliseconds. So all is nice and good. All right, so tests that you can do on the boat. I'm going to turn the computer off so you see that we lost communication and all the signals are there. All right, so things that you can do on the boat when you want to check a computer like this. All right, before you plug in the computer, you want to make sure the sensor grounds and fiber reference is not shorted. How you do that? Okay, I'm going to set up something in here and then we can see what that will read or not. Okay, so give me 1 second. Okay, I got the multimeter ready to go. I'm going to explain the connections and tests you need to do on the boat. So, okay, you are going to unplug the computer and let's say one of the sensors, let's say the TPS or any of the sensors in the boat that you can check for the fiber reference. So let's say, we have on the computer, we're going to have the fiber reference coming out on J2. You got J1 and J2. I got a mark in here. So this is J2 and this is J1. You won't know which one is J2 and J1 because the computer itself, let me put some light in here. J2 is where the ear of the computer is, and J1 is on the other side. And you can see those mark. Now let me flip this over so we can see the J2 mark. And if we go here, the J1 mark. So that's how you will know where are you. All right, so we're going to put first continuity test. Make sure the wire is not open. All right, so the first test that I'm going to do is I'm connected to the fiber reference, let's say on the TPS sensor, throttle position sensor, or the map sensor, either one of those. You're going to have 3 wires on each of those sensors. So let me get the diagram for that. All right, we got here the wire diagram for the Volvo Penta. I wanted you to see, okay, 13 and 18. All right, 13 is the map sensor, manifold absolute pressure sensor, and then the 18 is throttle position sensor. So those are the 2 sensors easier to get. We will have, if we follow, we have pin 2, which splices and then goes over to one of the pins on the throttle position sensor and one of the pins on the map manifold air pressure sensor. So this is your fiber reference. So you are going to connect, let's say, this is that wire right here. So I got one of my leads, the red leads from my multimeter connected to that sensor on the fiber reference. Again, if we zoom in, let me make this bigger and we can move this. Sometimes a little hard to capture that. with the touch screen. Perfect. All right, so again, coming from pin 2 on J2, as we have here, that's a fiber reference. I will go to pin A. You're going to have fiber reference, you're going to have a sensor ground, and then you're going to have the signal. 23 on the J2 is the signal produced by the sensor. So you will have, with the sensor disconnected, you will have 5 volts, sensor ground, and then an open. But you can do, if you don't know which one you are, because in here you got colors. I will again do the continuity test, and then you just go into pin 2, which you will see pretty easy. They're marked in the connector. You will see pin 1 mark and pin 16, and then on the other side 17 and 32. So I'm in pin 2. As you see, the second pin in here, that's a fiber reference. So if I don't know in the connector which one is A, B, or C, right, for the throttle position sensor, all I need to do is put the continuity. If it beeps, it's continuity to touch. Now let's say I unplug this from the sensor and I go over to the sensor ground, and if I touch it, because you need to do that, right? So you're going to touch the other 2 wires. I would recommend you to either get something like this. This is like a needle, sorry, a needle probe that you can connect to your meter. I'm doing this one hand and using my other hand to record, so bear with me 1 second. So you can go behind from the connector, right, or unplugging the connector. You're not going to stuff this hard. You're just going to touch it. All you need to do is touch. If we touch here, this should beep, and it's beep because that's a fiber reference. If I touch on the ground and that beeps, that means these 2 wires are shorted together, so you need to repair the harness. If you touch the signal and it beeps, then it's shorted to the signal, so that will need to be repaired. This is one test. The other test that you want to do, and let's say an event that you got a shorted wire to power, let's say, what you will see is, and this is the next test, so you're going to leave your lead, one of the leads on the meter, connected to that J2, um, 2, J22, which is again the fiber reference, and now we're going to go into voltage. So what I would recommend you to do is with a test light, this is a bulb that I put 2 connectors. I'm going to look into power. So I know I have this lead right here is connected to power. So this is a safe way for me to do the test so I don't damage anything in here. So I'm going to connect this and I'm going to simulate a short to power. All right, so this is a short to power through the 5-volt reference. Okay, so right now we got the lead in there. Now this lead's in here, and we're gonna use the other lead, and we're gonna touch ground. So let me put this probe in here. All right, so we had that in there. So what I wanted to do is with the meter as is, you're going to touch a ground. All right, let me turn the ignition on because otherwise I got no power. So again, computer is not connected, but we have a test light in there. So if I touch a ground, look at the meter. Now it's reading 13.2, and I'm in the 5-volt reference. That should be no 13.2. If I do that and I see anything but 0, you have a short. And again, you have to work on the harness. So again, the test light is not necessary. And here, what you will do is, because I need to simulate the power, right? So you're going to leave the harness connected and you're just going to unplug the computer. You're going to touch in here, as I'm doing, right, on J22. And the other lead, you're going to touch a ground with the ignition on. If the ignition on, you read that 13 volts, that means you got a short to power. And you're going to repeat the same thing on the ground. All right, so we're going into the same connector. We're going to go now into pin 3, which is the one next to it. That's the sensor ground, right? And we're going to simulate, again, a short on the sensor ground, a short to power, right? With the computer disconnected. So we can now supply power through a test light, and this is just me. This is reproducing a short. We leave that in there, and now we touch the ground, and we're reading 13 volts. That ground is shorted to power. We can do, and you can do the same thing
If you don't find a short to power, then now we're going to do the opposite. I'm going to create a short to ground. Obviously, on the ground, you don't you will not care about short to ground, but you have to do it because it's important. So we're going to connect now this test lead to ground, and I'm going to put it here in the fiber reference if I can with one hand. So bear with me again. I'm trying to do this live because you will not need to do this because you will keep the harness connected. All you'll be doing this, the test is in the connectors of the computer. All right, so we are now short to ground. So we're going to have the meter reading voltage, connector J23, sensor ground. Sorry, we got to go over to J22, which is the fiber reference, right? And we're going to do the same thing, but now this time we're going to touch power. So I'm going to touch here, and that fiber reference is now shorted to ground. Again, this needs to read 0. The fiber reference and the sensor ground with the computer disconnected needs to read 0 because the computer is not providing the ground. So if we do this, let's say a good reading on the sensor ground should be if I come here, right, and I touch that sensor ground and I touch into power, this should read 0 as is doing now. That would be a good reading, and that has to be the same reading on the 5-volt reference. If you read anything but 0, you have a problem in your harness. This is the test you can do to perform before you plug your computer to make sure that no harness is shorted and it will end up damaging your computer. All right, guys, I hope that you see all the information that I'm trying to share. This is again the wire diagrams, which I'm going to send this to Paul so he can do the checks on the boat. And I have marked, this is more for me than for anyone else, but in here I have marked most of the main signals, powers and grounds, and you can see fiber reference and sensor ground, which are J22 and J23, exactly as I show you here. All right, guys, thank you so much for visiting the channel. Thank you, Paul, for trusting my service, and I'm very happy to give you the good answer. The computer is repaired. All right, don't forget to subscribe. See you next time. Bye bye.